Step one is to isolate the radical. That's make sure the radical is by itself. Take a look at the equation, and it is. So I start out with not having to do anything. That's good news. Then since it's a square root and the radical is by itself, I would take the radical, and I know this is a lot of steps, but this gives you exactly what's going on, and I would square both sides. Squaring removes the radical so that you'd had 4x minus 3 equals 25. So that's the equation you're going to solve. Or that 4x minus 4x equals, add 3 to both sides, 28. Isn't that cute? Divide both sides by 4, x equals 7. But I cannot say for sure that x equals 7 until I check my answers. So I go back to the original equation always, and just in case. Is it true that the square root of 4 times 7 minus 3, is that equal to question mark 5? Well, this is 28 minus 3. Well, that's the square root of 25. The square root of 25 certainly is 5, and it checks. So that says that x equals 7 is my answer. First thing I will notice is that the radical is not alone. It's got a minus 4 with it, so I need to move the minus 4 to the other side, so that the square root of 3a minus 2, add 4 equals 5. Then I'm going to square both sides. So I'm going to square the square root of 3a minus 2 equals, I'm going to square 5. 3a minus 2 equals 25. Now I'm in a position to solve for a, so that 3a equals, add to 20. Isn't that cute? So that a equals 9. I like anything where I don't have to think a lot. Now I have to check my answer. Is it true that the square root, and I go back up to the top, of 3 times 9 minus 2 subtract 4, is that equal to 1? Well, this is 27 minus 2 minus 4, which is 27 minus 2 is 25 minus 4, which is 5 minus 4, which is 1. And it checks. This is one of these situations that the domain of the equation I'm solving is different than the domain of the original problem. 3a minus 2 has no denominator. 3a minus 2 has no radical. That means the domain is all real numbers. However, if I go up to the original problem has a radical. And I know that what's under the radical, or the radicand, has to be greater than or equal to 0. 3a minus 2 has to be greater than or equal to 0. 3a must be greater than or equal to 2, or a must be greater than or equal to 2/3. I've got half the number line that can't be a solution to the original problem. Because if I were to put anything smaller than 2/3 in, I'd have a negative number under the radical. And my answers in this particular instance need to be all real numbers. So that's why you have to check your answer, because once you square both sides, you've now changed the type of problem or the domain of the original problem, domain of the solution set.